question 2. This question is about period 3 of the periodic table. Deduce which of Na plus and Mg2 plus is a smaller ion and explain your answer. If we go to the periodic table, sodium and magnesium. Okay, well, we know magnesium has more number of protons, right? So already students would be like, including myself, fall for this trap. Therefore, Mg2 plus is the bigger ion, therefore Na plus is the smaller ion. But if you think about it, the smaller ion is Mg2 plus. Reason being is Mg2 plus has more protons with the same shielding. With the same shielding. And I recommend putting this question to a flashcard because you can apply this to any kind of iron, really. Why is this iron? If it's always about deducing this 2 marker, because more protons with the same shielding. 2.2, write equation show the represent the process that occurs when the first ionization energy for sodium is measured. It's going to be Na gas, arrow, Na plus gas plus E minus. Na gas, arrow, Na plus gas plus E minus. They really like asking equations about representing a process for first ionization energy or second. But the key idea is the one with the positive. This is just going to be 1 minus this. So if this is a positive 1, it's going to have a charge of 0, so nothing. And then 2.3, the first ionization energies of some period 3 elements are shown in figure 1. Complete figure 1 by plotting the approximate first ionization energy values for magnesium and sulfur. So magnesium and sulfur. So sulfur is going to be the one with 16 electrons, magnesium is going to be the one with 12 electrons. This one's magnesium, this one's sulfur. If you look at the general pattern, magnesium is not actually going to be, you can see that the first ionization energy tends to dip. So what it's not going to be is, put it here and then it's just going to be something like this where you ignore this. It's not going to be that. What's actually going to be is a dip. So somewhere around about 700, like here-ish. And the idea is going to go up to there, then slightly dip, then increase. And now what happens now? Well, for sulfur, it's at what? Here at 1000 and 1, 2, 3, 4, 5, 1040, 1050. So sulfur is just going to be at 1000. So here, here, slight dip, then increases, and that would be it. Obviously, don't draw the lines. Like don't draw them together. Just plot the points for magnesium, sulfur, and then it says explain why the first ionization energy of sulfur is different from that of phosphorus. So let's, before I even do this question, there's probably 2 marks for this and 2 marks for this, right? I had to plot 2 points and then this one 2 marks. Sulfur, if you look at sulfur, it has 16 electrons, so it's going to be 1s2, 2s2, 2p6, 3s2, 16, so 4, 10, 12, 3p4. Phosphorus, on the other hand, has 15 electrons. So phosphorus, I would say, yeah, phosphorus is going to be 1s2, 2s2, 2p6, 3s2, 15, so just one less, 3p3. And now you can clearly see the electron configuration in terms of the s and p orbitals. So why the first ionization energy of sulfur is different than that of phosphorus? Well, if you look at the p orbitals, because the rest of this is the same, so we don't really care about that. If you look at 3p4, 3p3, well, 3p4 is going to have paired electrons in the 3p orbital, whereas in phosphorus, each of them are going to have their own one. In phosphorus, it's just going to be like electron here, electron here, and electron here. Whereas in sulfur, it's going to be an electron here, electron here, electron here. However, it has one more electron, so therefore that last electron has to bond, has to pair with one of these 3 electrons. So therefore, it will pair. And remember, the paired electrons repel. So we can say the electron pairs, in which orbital? Don't say p orbital, because you could be talking about the 2ps, 2p6 orbital, but you need to be specific. The electron pairs in the 3p orbital, in sulfur, in S, repel. Paired electrons repel. Paired electrons repel. And what does that mean? Hence, we need less energy needed to remove the electrons. Less energy needed to remove the electrons. Hence, the first ionization energy of sulfur is different than that of phosphorus. And that is the end of question 2.